As a child, Adam Noble was obsessed with bugs. As a teenager, his fixation on some of the tiniest of them has led to million-dollar offers from venture capitalists. His research has now sent ripples through the water treatment industry, and check this out, it now holds promise in tackling a deadly form of childhood cancer. Tonight, we meet the Whiz Kid, 19-year-old Adam Noble.
I started doing this about 3 years ago now with my dad, going out and collecting these. A few times we actually had to break through the ice because it was so late on in the year to be able to get the water out. So it's definitely a lot easier whenever it's nice out like this. I designed a new technique on measuring the nanosilver particles in water, and I found that it was accumulating along this riverway. And I found that the main place that it was getting into the river was the water treatment plants. Then I was using an algae to indicate how toxic the nanoparticles would be in the water. And I found that as the nanoparticles were killing the algae, it would all concentrate inside of their cells. I managed to design a filtration system that could be incorporated into wastewater treatment plants and be able to reclaim around 99.9% of the nanoparticles back within an hour, and then be able to resell them again. There's about $4.2 million worth of the nanoparticles that I can reclaim back every year from Peterborough alone, and it costs around $700,000 to run the system every year. So that's a $3.5 million revenue. So that's pretty great for a municipality to have something like that. I've had offers in the past to be able to buy the system, but my main goal right now is to actually start up a company that I would own around the system, so then I'd be able to keep it here in Canada and even in Peterborough, so then we could have some job creation here.
Well, he's always been like that. He's right from a little guy. He's just always picked up things around him and examined them and asked questions endlessly. Our mantra was, get outside, go outside and play, get out there, and so he did. He was outside all the time.
Well, when I talk to my parents, it's usually from like right when I started walking. I was going around finding weird bugs and stuff like that and trying to figure out what they were. I've been able to do some of my research at Trent, and then it's kind of just expanded from there, and now I've been able to work in many different labs here. At the beginning, I did have trouble with my friends because instead of going out and playing sports with them on the weekends, I'd be having to stay in the lab and doing my research. And then once I started being able to do this amazing things, like when I went to Sweden, I got to dance with the Swedish princess and stuff like that. Like my friends now realize, like, wow, that's pretty amazing. I wish I could have been doing stuff like that. So last year, whenever I was trying to justify the need to remove the nanoparticles from wastewater, I was looking at lake trout embryos, and I found that when they were exposed to the nanoparticles, it was accumulating in their gills. And then whenever I grew the cells of their gills in a petri dish and then put nanoparticles there to see under a microscope what was actually going on a cellular level, I found that the cells were possibly turning into cancerous cells. So I thought that if I could design a nanoparticle that was targeted in its route of toxicity, I'd be able to kill off the cancer instead of causing it. And I was able to shrink the tumors by approximately 45% in 8 days, which is very fast for a chemotherapy agent. And I've been able to treat off skin cancer, lung cancer, cervical cancer, and neuroblastoma. And right now, I'm developing collaborations with Sick Kids, Princess Margaret, and Calgary on a treatment for the neuroblastoma. The weird thing I was finding with fluorescent microscopy was that the ER was it was all kind of invaginating into the nucleus.
But that if the nuclear wall broke down,
then it would, yeah. Okay.
He's come across something original and new, and we're working in a field in kids' cancer where half the kids with the particular cancer we study, which is called neuroblastoma, will likely die from their cancer because we have no real treatment, we have no cure, and we're looking for new ideas. And what Adam has come up with is a new idea. And that's great. There aren't a lot of these amazing new ideas in cancer, and his is one.
Like the density change. Yeah. Instead of focusing on, say, breast cancer or cervical cancer that a drug company would buy and make a lot of money from it, and I would make a lot of money from it as well, I wanted to focus on something that would benefit people that couldn't really help themselves.
At one point, we thought he was going to be an artist because he's very artistic and he was very into sculpture as a young student, and we knew whatever it was that he put his mind to that he would focus on and do well, but we didn't know what it was going to be.
I met with Prime Minister Stephen Harper a few months ago about my research, and he was very excited. It was really great. I was not expecting him to be I was really nervous to go and meet with him, and then he was very personable and easy to talk to, and he knew about my research, so it was great to be able to have an in-depth conversation with him. So, when I went to the Nobel Prize this year and I got to talk to the laureates that won and also past laureates, I realized the real potential of doing science, and my main mandate now is not to go and make money, it's to be able to change the world in a positive way. So that's really my motivation now for my research.
Pretty inspirational young man. Now, this probably won't surprise you. In the fall, Adam will attend medical school, and while he's there, a team supervised by researchers at Toronto's Hospital for Sick Children will start the process of pre-trials for his cancer research.